Good afternoon, everyone, and welcome to this session of Computer Vision and AI for Beginners. I am Jared, and I will be leading you through today's session. Okay, so let's just go ahead and dive right in. Before we really get into computer vision, we really need to talk about AI. So, what is AI anyway? AI stands for artificial intelligence, obviously. Artificial intelligence, we will break it down, really is two different words, right? So it's artificial, which means not real. In this case, it's meant to be as close to real as possible, but isn't quite real. And intelligence is, in this case, the ability to think. So if we relate that to computer systems, it's actually the ability for computers to think. In this case, thinking is not exactly what probably most people are familiar with. In the case of artificial intelligence, thinking is mostly the ability to recognize patterns and based on those patterns to then make decisions or do certain things. So, where can we find AI nowadays? I would say on average, the average person in a day probably interacts with AI many more times than you probably think. AI can be found everywhere around us nowadays. Probably the most common places that you would find artificial intelligence being used in Singapore right now would be if you were to find something that you would like more information about, say maybe a restaurant or information like what time are your football matches being played on the weekend, and you open your phone and you go to Google and you Google, hey Google, what time is my football match this weekend, and you search that information. Now it doesn't really seem like it because I guess searching online is second nature to a lot of people nowadays, but Google's search algorithm is actually a form of AI. Another very common place you'll find AI is in ride-hailing apps like Grab and Tada and things like this, where they use artificial intelligence to match up people who are trying to find a car and drivers who are around the area. Broadly speaking, AI can then be split into two different categories. We have weak artificial intelligence and strong artificial intelligence. Now, weak artificial intelligence can also be called narrow artificial intelligence, and it's based entirely on recognizing patterns, as I previously mentioned. So in this case, I would say left, right, left, right, left, right, and I ask someone what's the next word, is it left or right? Most people will be able to recognize that after left should be right. In this case, it's similar where computers are trying to look at these different data points and make an analysis of it and conclude that the next one would be right. In terms of everyday use nowadays, you will most likely see something like this in facial recognition. If you think about it, things like your Apple Face ID and Google, whatever it's called, for Android devices, or locks that unlock based on your facial recognition. Now, if you look at the image that's on the screen, you can actually see that there are different points around the nose, the bridge, the forehead, cheek, jaw, chin, things like this. And these different data points are then used by an artificial intelligence computer system to recognize patterns to determine who this person is or whether this person matches to anyone that is within the database. Weak artificial intelligence, as you might think about it, might have limitations, and it does. It's in this case, major limitations are things like unable to simulate real thought, is only really able to analyze what is available and then proceed on from there. It's not able to think up of abstract ideas or things like this, but it is still extremely powerful. And it is the predominant form of AI today. And what I mean by that is strong AI, which is also known as general AI, does not exist in a practical form. Theoretically, people know what it is, but you're not going to find it out in the wild anywhere because you're mostly only going to see it in media like movies and books. So, I mean, people might probably recognize Bumblebee on the side there waving to you. And that is an example of strong AI, something that is able to think and generate thoughts of its own. But this is not something that actually exists in the real world today. And it's not something that anyone is aware of that we are close to being able to actually achieve. Because of how powerful, I guess, strong AI is, you could say that it's meant to match real human thoughts. So the real true ability to think and grasp abstract concepts and ideas and apply those abstract concepts and ideas. So it can match or even surpass the ability of humans for thoughts. Now within weak AI, you generally have two different categories again, which is rules-based and machine learning. Now, rules-based AI works on using existing knowledge. If you look at the little graphic I have there, is relatively traditional in the sense that it uses existing information, so data in this case, and someone who has pre-programmed that data to do computation and come up with a result. In this case, it differs quite greatly from machine learning because machine learning learns new knowledge over time. Now, when I say learns new knowledge, I don't really mean actually learning. So as I mentioned, AI is not able currently to really learn abstract concepts and ideas. What it is able to do is learn to recognize new patterns over time. So in this case, the graphic you can see now has changed from data and results. So the data that it receives and the result that it receives, to combine them together to compute, to come up with the necessary program to find that result. Now, rules-based AI is a top-down approach. What this means is that, as I previously mentioned, these rules have to be predefined. That means someone has to sit down manually and enter them into a computer system. The program has to be written around it so that they are able to use these rules, these predefined rules, and it's not very easily scalable. That means if you want to change the contents of that program, the likelihood of you needing to go back and rewrite major portions of it is very likely. It as I mentioned, uses predefined rules that again are not formulated or generated by a computer system usually, but by people, and in this case the programmers, who have defined these rules that the computer system uses to reach its results, which are conditional in outcomes. So what does conditional mean? Let's take the example of something that is automated. Let's say automatic lights or automatic doors. Okay, so if in case of an automatic door, you have a sensor that sees that, okay, there is an object a certain distance away, and when it senses the object is under a certain distance, it opens the door. Similarly, if you have automatic lights, maybe you have programmed it to only turn on after a certain time. So maybe if it's after 6 p.m, you turn on the light. Now, from both my examples that I just used, you can see that rules-based AI is usually used to automate processes. So in this case, automatic doors, automatic lights, automated factories, and things like this. And general AI, weak AI is built around this system. Now, we have machine learning, which learns to recognize patterns over time, as I mentioned. So what happens is that machine learning is different from rules-based in that it is scalable because it recognizes patterns over time and it adapts to those patterns as it recognizes them. Now, a very big thing in this world right now, of course, is COVID, right? So machine learning and artificial intelligence in general has been used for many things to deal with COVID, including detection, elimination of processes for certain constructs such as vaccinations and determining different genomes and things like this for different strains of COVID. So machine learning looks at these things, goes through a sequence of data to see what is different, and comes out with something new to see whether it is predominant or prevalent. It can be used to both automate processes and predict outcomes. So in this case, like I mentioned previously, COVID, right? It runs through different simulations and it sees whether it believes certain things that have become indicators will hold true in things like vaccines. So it runs simulations of different compositions of chemicals, for example, to see whether these chemicals can affect certain diseases or things like this, to see whether it is useful. But at the same time, it's also used to automate processes. Like, I mean, the lights example is extremely simple example, but it can be scaled upwards using machine learning. Most computer systems nowadays use machine learning as opposed to simple rules-based, because it's much more easily scaled. So it can be adapted to different things more easily. You can expand upon the code more easily because it is generally made that way. So now that we've talked about AI, let's ask, what is computer vision? If we look at AI, think of AI as an umbrella term. Machine learning is one component, one subset of artificial intelligence, and computer vision is another. So computer vision is a subset of artificial intelligence, and it's used to gather, process, analyze, and study imagery. Now, imagery can be anything from photos, still images, to videos, scanned documents, and things like this. Anything that has a visual representation. And for it to have a visual representation, you need to use a visual input to receive that data. The most common form of this, of course, would be things such as cameras, which are able to both document still imagery and also moving images or videos. But you can also use certain devices such as scanners to be a visual input. So what's the difference between computer vision and human vision then? So how do humans recognize things? I'm going to show this picture now, and I'm sure everyone can see, oh, okay, this is a picture of a turtle. And the reason we are able to know that this is a picture of a turtle is because we have our brain, which is a very, 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 very powerful computer system, basically. Okay, it takes whatever imagery that we receive through our eyes, automatically decodes and interprets them. So in this case, it looks at this picture, it sees a familiar shape, familiar textures, familiar colors, and it draws all those together to form the conclusion that, okay, this is a turtle. Now, computers don't see the exact same way that humans do. For example, I took this picture and I ran it through a program to interpret it in hexadecimal form. Okay, so this is what it actually looks like to a computer. Or rather, I opened this image with a hexadecimal interpreter, and this is what it looks like. So you can see a bunch of numbers and alphabets. Hexadecimal is a certain type of language that is far too complex for me to really explain right now. But as you can see from this, computers do not see things the same way humans do. So what computers have to do is then, when you receive their imagery, to take it, analyze it, and search for patterns. As I previously mentioned, colors, textures, shapes, things like this, and try to draw conclusions based on these patterns that it sees to determine what it actually is. And I will show you an example of this later, where when we are doing our practical AI model training, where you will see it's quite easy without a sufficient sample size to receive false positives and as well as false negatives, I guess. So that's really it for me in terms of the theory portion of computer vision and AI. So we're actually now going to go on to using our online platform to do a little bit of coding. So to access that link. It's on the slideshow, and I believe it's also being shared in the chat. So you guys can go ahead and open it. You don't need to download anything. Everything will be loaded online. It might take a little while to load, so don't worry. If it does, just give it a little while. And if you're not able to follow along, don't worry, because this video will be available after the session as well on the Make IT Facebook page. So, okay, let's go ahead and get to that. Okay, so now this platform we're going to use is an integrated development environment, or also known as an IDE, for UBTech robotics. It is called uCode, and it actually can be used to work with a lot of different interfaces and devices. In this case, since we do not have an external device, we will just be using this little corner in the right where you see the lion, which is called a stage, to control things within it to do certain things. So in this case, we are going to be creating a virtual seascape, as has been, I think, advertised. So we are actually, the first thing we're going to do is, let me introduce uCode a little bit. uCode is a platform for people with beginner levels of coding. It uses a block-based interface, and what it means by block-based interface is that instead of having to type out code, the code has been condensed down into visual blocks, for example, and I believe this is too small, so let me make it bigger. For example, right now, if I have to click on this, you see all these different blocks on the side. It's just too small. I think it's a bit too small still. Okay, so different blocks that do different things. So you can see that the blocks are color coded, and each color does a different thing. Okay. We are going to be working with things that are called sprites. In this case, sprites are generally just images that have different frames to them. So we are not going to be using a lion. So we're going to delete the lion by pressing the little X in the yellow circle above sprite 1. Okay, and we're going to be clicking on this blue color circle with a mountain in it, and clicking on choose backdrop, which is the magnifying glass. We are going to click on underwater, and we're going to select ocean 1, or I guess you can select any one that you want. It doesn't really make a difference. I'm just going to use ocean 1. So you can see now that the backdrop of the stage has changed to this. So this is our stage setting now. I am going to show you guys a few things that we are going to be doing. And we're going to be going through some basic coding concepts as well. In this case, conditional statements, loops, and triggers. Okay, so we're going to be adding new sprites to this. So I'm going to move my mouse over to this yellow circle with this white color thing in it that says choose sprite. I'm going to click on the magnifying glass again. You're going to see a whole bunch of different sprites here, but we're going to click on animals. And right there we have turtle, and I'm going to use turtle 1. So now we have this big turtle here, and it's a bit too big for the stage. So what I'm going to do is, if you look beneath the stage, you have something that says size, and we're going to change the size to 30. Now this is a percentage base, so if you make it higher than 100, it's going to become even bigger. If you apparently 193 is the biggest, so we're just going to change it to 30. Of course, if you want to, you can make it bigger, but 30 I think is a good size so that we can see this turtle when it moves around. Now, the objective here that we are trying to do today is we're going to take this turtle and we're going to first program it to move back and forth across the screen. If you go to the left-hand side where it says code, and there's a blue color tab, next to it is a costume tab. If you click on costume, you're going to see that the turtle has 3 costumes. Okay, so these are our different frames, but you're going to notice that these costumes only move in one direction. So if we have our turtle move from the middle to the left to the right, it's always going to face the same direction, and I think that's a little bit boring. So what we're going to do is we're going to click on turtle 011. We're going to right click and we're going to duplicate. Now the duplication will be right underneath it, so we're going to drag it right to the end just so that everything is kind of in order. Now we're going to do the same thing for turtle 012. We're going to duplicate it, drag it to the end, and we're going to do the same thing for turtle 3. Duplicate it and drag it to the end. So now if you look, you should have the frames for turtle 011, 2, 3, 4, 5, and 6. But they're all still facing the same direction. So what we want to do now is we want to go to the middle where it says flip horizontally. So for number 4, 5, and 6, we're going to click on it and we're going to flip it to the other side. So now we have a turtle that can face both directions. And when we code it, we are going to actually use these frames to animate the turtle. So the first thing we need to do here is look at events. Now events have a bunch of different things, but mostly it's you can think of it as a trigger. When this thing happens, begin to run the program. So for simplicity's sake, we're going to use when green color flag clicked. Oops, that's huge. When green flag clicked, do something. So the first thing we have to do is we need a loop so that the turtle will continue to move back and forth. So we're going to go to control and we're going to look for forever and we're going to drag it and connect it. Now you can see when I'm connecting it, there is this gray color shadow. This means that the block will connect. If there is no shadow and I let it go, it's just going to sit on its own. But when there's a gray shadow and I let it go, it connects. So for blocks to work, it has to be connected to an event block. Okay? Otherwise, when you run the code, nothing's going to happen. We are then going to use motion, and we're going to go to scroll down to look for change x by. Now we can do it change x by 10, and if we play, or rather start the program, which is by using the green color button with the white color flag beneath the stage, you're going to see, whoops, it disappears off the screen and stops moving. Okay, so what we want to do now is we want to make it so that when the program starts, the turtle first moves back to the middle of the screen. So let's go again to motion. We're going to look for this go to x and y, and we're going to change both to the 0 and 0. So now we press the start button again, which is the flag button. You're going to see it start again in the middle. Now, one thing to remember about the stage, and if you look here, change x by 10. Why is it that it say x and y? It's because you can think of this stage as 4 quadrants. Okay, so you have your x and y axis. So you have your quadrant here, your quadrant here, quadrant. Give me a second. Okay, so you have one quadrant here, one quadrant here, one quadrant here, and one quadrant here. Okay, so you have your x-axis and your y-axis. So anything on this side of the y-axis is a positive in the x-axis. So basically, to the right of the middle is positive and to the left is negative. Similarly, anything up is positive on the y-axis, and anything below the middle is negative on the y-axis. So if we want our turtle to move to the left, we actually need to change it from 10 to negative 10. And if we start the program again, you're going to see it moves to the other side. Now, the thing here is that, as you can see, when it moves to the other side, it doesn't stop moving and disappears off the edge. We don't really want that. So what we're going to do is we are going to put a conditional statement here. And we're going to put the conditional statement, which is an if-then. Okay, and we're going to connect it inside the forever loop. Okay. Now, we actually have it quite easy because, like I mentioned, block-based programming or coding has been simplified down so that a lot of the code is very standardized. So we don't need to figure out anything for a lot of things on our own. So actually, you're going to click on sensing, which is these light blue blocks here. You're going to see this on the first one. It says touching mouse pointer. If we drag it out, we can actually put it inside this little block here. Okay. So now it's if touching mouse pointer, then do something. We're going to click on it, and you're going to see mouse pointer has two options. We can either use a mouse pointer or edge. So we are going to be using edge. Okay. So this means now that the edge, once it hits the edge of the screen, something's going to happen. Okay, now we're going to put this here. We are going to put another conditional statement. In this case, instead of just an if-then, we're going to put an if-then-else. Now, the difference between an if-then and an if-then-else means is we now have an if something is true or something is false, then do this. Otherwise, do something else. So, for example, using my light example earlier, if the time is after 6 p.m. and before 5 a.m. maybe, turn on the lights. Otherwise, turn it off. So outside of the time range of 6 p.m. to 5 a.m., turn it on. Otherwise, turn it off. So in this case, we want to see whether which direction it's moving in. And the way we're going to do this is we're going to use something called a variable. Now, a variable is just, you can think of it like a box. You can put anything inside this box, and in this case, we are going to be putting a temporary value inside this box. Okay, so we're going to make a variable and we're going to call it turtle direction. Okay, you can name it anything you want, but I find it's usually helpful to give your variables a name that's kind of self-explanatory, so that if you're looking back at it later on or someone else looks at it, they can quite quickly figure out what it does. Now, we don't want it to affect all sprites. We only want it to affect this sprite, which is the turtle. So we're going to click on this for this sprite only, and we're going to click OK. So now you're going to see on the stage in the upper corner, that's affecting turtle 1, the variable turtle direction. Now, the simplest way to do this is to use the directions rather than giving actual direction, we're giving the coordinates based on the x-axis. So in this case, if it's moving in the left direction, we want it to have the value of negative maybe 5. And if it's going in the right direction, we want it to have the value of 5. Okay, so I am going to go up here and I am going to now set a value for it so that when the program starts, it has a default value. So I'm going to go to my variable and I'm going to select set my variable to 0. I'm going to put it on the top, outside of the loop. Okay, and we're going to click on the word my variable, and you're going to see now turtle direction. And I'm going to select it, and I'm going to give it the value of negative 5. Okay, so now we are going to go to operators. Okay, and we are going to look for the operator that says equal to 50. And we're going to put it in here. So we are going to check on the direction based on the value of this variable. So we're going to check whether it's -5, and if it's not -5, it can only be +5. Okay, so now you see that there's a blank hole here. We're going to click on the variables again, and we're going to select turtle direction and drop it inside here. So what happens when it touches the edge and it's moving to the left? We want it to then turn around and move to the right. So to do that, we then need to change the value of turtle direction from -5 to +5. Okay, and one way to save time going back and forth between the different categories of blocks is we can right click and duplicate a block. Now it's a little bit iffy because if I right click and duplicate the forever loop, for example, you're going to see it duplicates everything. So everything that's underneath the block is usually duplicated. So if you have a large chunk of code, it can be difficult to duplicate blocks, but if it's just a single block like this on its own, it's easy to duplicate. So right now we have, if the turtle direction is -5, we change it to 5. Else, we change it to -5. Because if it's not -5, that means it's a +5, and we want to change it back to -5. So now we no longer want to change x by a constant value. We want to change it to the value of the variable. And if we start the program now, you're going to see the turtle is going to bounce back and forth. But you're going to notice that the sprite is not changing frames. So for it to change frames, we actually need to you do more conditionals. And I apologize ahead of time if this gets confusing, but because of the way this program has been made, this uCode, we are going to be nesting a lot of conditional statements. Now, nesting of conditional statements is actually something that is common in normal programming, but in my opinion, looking at it in text is actually a lot easier to recognize and understand than using blocks in this case, because the blocks need to keep nesting inside of each other and it becomes quite messy. So I'm going to take this now, I'm going to choose an if then else block, and I'm going to put it underneath to change the x by. Okay, inside that we're going to put another if then else, inside that we are going to take another if then else. So an if then else with an if then else inside the if then, and another if then else inside the else. That makes sense. We are going to deal first with the turtle, changing the turtle sprites, the frames going to the left. So to do that, we need to check for this, if turtle direction is equal to -5. So I'm going to duplicate that and I'm going to drop this in here. So everything that's inside this portion of code is related only to if the turtle is moving to the left. Okay, so the first thing we want to check is then what frame is currently on. And the easiest way to do this is to use a new variable. So we're going to make another variable. We're going to call it maybe turtle sprite, and we're going to make it for the sprite only. Now, if we look again at the costume, you're going to see moving to the left has 3 frames, and moving to the right has 3 frames. So we are going to be using a value range of 0 to 2, because you have 3 values, 0, 1, and 2, which correlates to first, second, or third sprite. Okay, so we are going to start at the top, which is we're going to go to operators, and we're going to go to equals. Okay, and we're going to change it to 2. Now the reason we have to start at the end, which is, that means if turtle direction is equal to 2 rather than starting from if turtle direction is equal to 0, is because of one of the limitations of uCode, but also because coding is usually sequential base. It means whatever comes first is processed first before what comes next. So if you have a bunch of different conditionals that check for different things, whatever you want to check right at the beginning should be right in front, and whatever you want to check right at the end should be further down. Okay, so now remember, we want to have the values 0, 1, and 2 to control the sprites. So if the turtle sprite is at number 2, that means it's at the last frame, and we want it to go back to the first frame. So we're going to set turtle direction to 1, and you're going to go click on looks, and we're going to go switch costume to turtle 0, 1, 1. Okay, now we're going to copy this, and we're going to paste it here. Copy this, and we're going to paste it here. And then we can duplicate this as well and put it here. So now that we checked for 2, we need to check for 1, which is the second frame of the turtle. So now we're going to set this to, that means after 1 should be the next frame, which is 2. And we're going to do this in such a way that we change it to the last frame for the costume. And the last one is if it's not 1 and 2, it has to be 0. So we change from 0 to the next value, which is 1, and we go color costume 2. Now you can go ahead and actually duplicate this entire thing and drop it in the else section here. Okay, and we're going to do the same thing, but instead of turtle costumes 1, 2, and 3, we're going to do 4, 6, and 5. Okay, so now if we just try to start the program again. Ooh, what happened here? Give me a second. Let's see what happens here. Sorry, give me a minute. So now we come to one of my favorite parts of coding, debugging. So a computer, in this case a coding bug, is anytime your code doesn't do what you think it should be doing or want it to do, and then you have to go through a process of debugging, which is trying to figure out why it's not doing what you want it to do. So let's see now. So this works. I'm going to change this also. Now again, when we start our program, we want it to reset to the default system. So we actually want to change always switch our turtle costume to 1. Okay, so that it's always facing the same direction, which is left. So now if turtle direction is equal to -5. Okay, because it should not be turtle direction, it should be turtle sprite. Set turtle sprite. So when doing this, be careful that you don't accidentally use the wrong values. I'm going to delete this, and I'm going to just copy this and change the values again to 4, 6, and 5. I'm going to attach it in here now, and I'm going to reset and start the program. Now you can see our turtle is moving back and forth. But if you look at it, our turtle is moving back and forth at a very, very manic pace. It's going back and forth really quickly. So what we maybe want to do is we want to make the code at the end of each running of the code to make it pause for a split second. So we're going to go to controls. We're going to select wait. So wait does exactly what you would expect it to do, is it tells the program to wait for however many seconds you put. So I'm going to put it right at the end here. Okay. And I'm going to change it from 1 second, because if I put it at 1 second, it's going to be really slow. I'm going to change it to 0.1 seconds. And if you start the program now, it's slower, but doesn't look like your turtle is being fast forwarded through its motions. Okay, so there we go. We have done our first program. And now we need to go slightly further. This is the introduction to coding, right? Like I mentioned, you have your conditional, you have your loop, you have variables, but where is the AI? And the AI comes now. So we're going to click on this little blue button in the lower left corner, which is here. And we're going to wait for our extension to load. Now, what we want to enable is this extension here called AI. Okay, and if you look here, it says disabled. If you click on it and give it some time to load, it will go from disabled to enabled. Okay, so once it changes from disabled to enabled, we can go and click on the blue arrow button in the top left corner, and it'll bring us back to our code. And you can now see we have a whole bunch of new codes called AI. To get started with it, what we want to do is we want to train a model. And if you click train model, this will show up. In uCode currently, we have two different kinds of model training. We have picture classification, which is, you can see from the picture and it's trying to demonstrate, it's looking at whatever is on screen in the camera screen view and trying to figure out what it is based on the models that we train. Otherwise, we have post classification, which is seeing how people stand and arrange their body. But today we're going to be using picture classification, and we click on it, we come to this user interface for model training. Okay, so now a model in this case is an AI model, which is basically kind of like your predefined rules that I previously mentioned. And for each rule, we're going to use something called a class. Now, in my personal experience, when using something like this, we want to have a class for whatever pictures you want to recognize. And also we want to have an additional class as kind of like a neutral classification. Because as I mentioned previously, the computer uses things such as shapes and colors to kind of do its recognition. And if you don't have this neutral class, what can happen is you can come up with a lot of false positives. So for example, if your picture that you're trying to recognize has a certain color, right? Like it's very common, maybe the shade black, for example. If you don't have this neutral class, it could be that anything that is black or dark in color will automatically be marked as a positive. So you want to have a neutral class. Now, I also find it very helpful to name our classes something that helps us identify it easier. So we're going to click on this little pencil and we're going to change the class name from class 1 to neutral. We have two different ways to add sample images. We can either use a camera. So for most cases, it's going to be a web camera, or we can add static images that we have already saved to our computer. So for the neutral here, I'm going to use the camera and I'm going to click on it. And apparently I need to turn on my camera. Okay then. Let me give me a second here. save as. Okay, right over here. And open. Okay, I'm going to do that again. I'm going to go to AI, train model, picture classification. So rename this to neutral. And I'm going to open my camera. Okay, so there. Now, as I said, in this case, I'm using my web camera on my laptop. So it's going to have the picture there. And to add images, I'm just going to click on photographs. So usually you want to move around a little bit so that it has more sample images. Now, the more image samples that it has, the better it is for it to recognize certain things. And usually in this case, it's because at different movements or angles within the picture. So for example, if you can see here, my head is moved to one side, here my head is moved to the other. It's just simpler, easier this way to generate, to match up to whatever picture is available to it. Now for my class 2, I'm going to name it turtle because this is what I want to recognize. Now I'm going to add images here by clicking on the folder icon, and you can either drag or browse your computer for it. So I'm going to browse by clicking the example images. Now I have 5 different images here. Okay, but the one limitation of uCode again is I can't select all the images at once. I have to select them individually. So I'm going to add them individually. And you can see from each picture that they're all different pictures of turtles. I only have 5 samples here, and you're going to see that all of them have some relatively similar colors. In this case, all the color of the water that they're in. So because of that, it's very likely that we can run into some false positives. So ideally, I would want to have even more sample images. The more, the better. Okay, so that the computer system can try and match up better. So from here, if you want to add more classes, so for example, I add a type, I can add a new class. So let's say, for example, if I want to add jellyfish, because if you look at my sample images, I also have a bunch of jellyfishes here. Okay, but I am not going to actually do it, so I'm going to delete this class type, sorry. I'm going to start training. Now, as before you start training, you see here there is a bunch of different options. You can safely ignore them now for now. It's basically how fast you want the system to try and train. So for here, we're going to just click start training. Give it a couple of minutes to start. It's actually relatively quick once the system gets running. Of course, the more images you have, the longer it takes to train. In this case, it's taking a little bit longer. It's because we are using the web interface. So the training has to take place on the end of the servers that are running this interface. You can see once it starts training, it's relatively quick because there are relatively few images to process. So now you can see the neutral is 100%. So even if I tilt my head one way, I tilt my head the other way, it's still relatively high in its recognition patterns. So now I'm going to show a picture to my camera of a turtle. Okay, so in this case, I'm going to show here a turtle, and you can see that now it changes to turtle, which is over 99%. Okay, but if I move it down, it's going to go back to neutral. Okay, so only when I have the turtle in the middle that's quite high. And I don't believe this is a picture of any of the turtles that I have in the sample images. So you can see it's doing its recognition based on certain parts of it, such as maybe the shape or the textures within the image. After we are sure that our model works the way we want it to work, we are going to rename it. So in this case, model 1, I'm going to name it to seascape. Okay, and I'm going to export the model. This takes relatively little time. So now we have trained our first AI model. We are going to use more loops and conditions for it to work. So the first thing we want to do is we want to go to AI and we want to load load the seascape AI model until completion. This is just so that internally it starts to load the model so that it saves a little bit of time when it's doing the recognition. Now the next thing we want is maybe we don't want our turtle to be visible from the start. So I'm going to disable it, turn it off, and now I'm going to wrap this forever loop in another forever loop. We're going to go controls and we're going to click forever. I'm going to put it here first, and I'm going to take everything and drag it inside here and reconnect it. Now I want to then only run, actually I don't need to reconnect it yet. I only want to run all this code if I show my camera a picture of a turtle. So I'm going to go to control and I'm going to go use an if then. We're going to go back to operators and we're going to look for more than, which is this one. Okay, so now you could have, if you noticed earlier, the AI recognition model is based on 100%. We want a relatively high recognition level, so maybe 0.99, 99.9%. Okay, but in this case, uCode runs that percentage as out of the number 1. So 99% will be 0.99. Okay, I'm going to take this and I'm going to drag it in here. I'm going to click on AI. And we're going to go confidence of model for real-time videos. Then we're going to drag everything and we're going to drop it in here. Now, we're going to click on confidence of model and we're going to select seascape for real-time video turtle. Okay, and then we can go ahead and one last thing is we want to make sure that after it recognizes it, our turtle shows up. So we're going to click on looks. We're going to put show. Okay, and we're going to hide at the start here so that it resets again. We want to make sure it resets to default settings. Okay, so now I'm going to run the program and you'll see that the camera detection window has showed up here. Now, if you look at all the blocks, you're going to see that they're outlined in yellow. This means that currently this code, those blocks that are outlined in yellow is running. And as you can see now, neutral, nothing is happening. Nothing is happening on the screen. Values of the variables are not changing. But the moment I put a turtle onto the screen, okay, and it recognizes the turtle, it starts to run the code, which is the turtle appears and starts swimming back and forth. Now, let's talk about a couple of the limitations for uCode. Unfortunately, it is, as I mentioned, not scalable, right? Previously about rules-based AI. So in this case, every time we want to add something to our model, for seascape for example, we actually need to go back and make a new model. We can't just change the current model. So we want to make a new model, we have to again train a model, and we cannot select a previous model. If so, I click and then we have to start all over again. So in this case, for example, right now, if I want to do something similar to maybe a jellyfish, for example. Now, if you add the sprite for jellyfish, animals, jellyfish. Again, the jellyfish is huge. We can change it to 30%. And if we don't want our jellyfish to move up and down instead of left and right, it's quite simple. Now, if we don't want to spend all the time redoing all that code again. So what we can actually do is we can actually take this and we can click on it and drag it to the jellyfish, and it will automatically copy all the code. Okay, so in this case, then we will want to train a new model with jellyfish. So I'm going to click on extension, AI, train model, picture classification, neutral, turtle, and jellyfish. Okay, so neutral, take picture. Okay, turtle. And my 5 turtle pictures. And jellyfish, add my 5 jellyfish pictures. Now, as you can look at these jellyfish pictures, you can notice that some of them have relatively similar colors to the turtles in terms of water. So that's another case where you might run into a false positive, false negative, which is why the larger your sample size, the better again. Okay, so similarly, we start training. Okay, so now we have our model, and again, if I show the picture of a turtle, turtle's pretty high, right? 99%, but jellyfish is not 0, as you can see. And the reason for this is most likely the color of the water. So now if I use a jellyfish image, let me find an image that is not one of those that's in there. So for example, this one. And I show it here. You can see it recognizes the jellyfish at over 99%. Okay, so we have done our model and we want to train it. We just call it seascape 2. We're going to export our model. So for our jellyfish, we can't then use turtle direction and turtle sprite. Okay, so we're going to make 2 new variables, which is jelly direction and jelly sprite. Okay, and we're just going to replace everything here with jelly direction. This is the jelly direction. Replace this with jelly direction. We're going to make sure that we change everything so that it's correct. So if it still says turtle direction, we want to change it to the jelly direction. And if it says turtle sprite, we want to change it to jelly sprite. Now, usually I would say it's perfectly fine to leave little bits of blocks hanging around. But if we are talking about syntax coding, then obviously you want to make sure that you don't have any random code lying around, unless it's properly commented out. So I think I've changed everything. So I'm going to change model to seascape 2 and for real-time video to jellyfish. And this one, seascape 2 turtle. Okay, 2. Now, one thing here that is not really needed is that your jellyfish sprite really only has one loop to it. We don't want it to flip around, but if we do so, for example, costumes, again, we duplicate, and duplicate. We can flip it vertically so it's upside down instead of up and down. And we go back to code. In this case, we want it to go up and down instead of left and right. So away, pull this away. away, throw this away. Okay, so delete all this. Check direction. Okay. So instead of change X by jelly direction, we want to change Y by jelly direction. And we restart the program now. And we show a jellyfish. So you have your jellyfish going down, and it's not changing properly. Oh, because it doesn't change to turtle. So we change it to jellyfish 1, change to jellyfish 3, change to jellyfish 2, change to jellyfish 4, jellyfish 6, and jellyfish 5. And try it again. Show the jellyfish. Well, it's going backwards. But generally this is ideal. So now if I were to show a turtle, let me find a picture of a turtle again. Let's look for a different picture of a turtle this time, maybe this one. See whether I can recognize it as a turtle. So you can see now it can't really recognize it. Okay, because it didn't have the... It recognizes it mostly as a turtle, but it can't hit that magical 99%. So I'm going to look for another picture, maybe this one. There, now you can recognize the turtle, and so you have your turtle going back and forth. So yeah, so there we have it. We've created our seascape even though our jellyfish is going backwards. Let me see really quickly if I can fix that. Oh, right, because now it's going backwards, so up should be positive and down should be negative. So if we do it now, and I show a jellyfish, so you can see now your jellyfish is going in the right direction. And just for one last one, if I show my turtle, there we go. Okay, so we have now created a seascape using artificial intelligence to control whether the animals appear or not. That's the end of the practical. Actually, that's the end of the entire session. Yeah, so that's the end of the session, and I hope you guys enjoyed and learned something from it. And thank you for taking the time to attend this session. There is a little feedback that you can provide, and we would appreciate if you can provide it at the end after the session ends. But yes, thank you everybody for attending today.